Okay, I want to show you some information here from this unit. So a review of scientific notation. I'm going to let Tyler DeWitt handle that right there for page 1. Just a quick reminder on page 2, there's some good videos. You never put times 10 in your calculator. You handle that with EE or EXP. And depending upon what calculator you have, and I will give a plug for this TI-85. You can buy one of these used for less than $20 on eBay. To me, this is the best graphing calculator. It has built-in polynomial solver, let's say third degree polynomial and everything, all built in. So this awesome calculator. If you want a nice graphing calculator, and by the way, it'll do these problems. You can go to it'll do the 999th power. So a great calculator. All right, I'm going to let Tyler DeWitt handle that. We're going to talk about units of measurements, conversions, and sig figs during this unit. This is a really nice write-up. So I don't remember, I took most of this, so a lot of this is not mine, but really good stuff. Metric prefixes, and it really goes through the history of developing proper units that are agreed upon. Okay, in the metric system, there are these 7 units, SI measurement units of distance, mass, time, electric charge, temperature, amount of substance, and luminous intensity. Then anything else in the world can be described with one or more of these units combined. Now, acceleration would be meters per second squared, which would be distance divided by time, right? The rest of these down here are derived units. So in the metric system, there's 7 base units right here. 7 base units. And everything else is derived units from there. Now, I'm going to show you in the metric system how easy it is to convert from one to the other to make things higher or lower. For example, if we want to know how many miles are in like 25 feet, or how many miles are in 25 inches. In the English system, that is very, very difficult. But in the metric system, all we have to do is move our decimal right or left, the same as in this chart. So giga is 10 to the 9th, mega is 10 to the 6th, kilo is 10 to the 3rd. For the prefixes, our base unit is 10 to the 0. Now a base unit might be seconds, it might be liters, it might be meters, it might be bytes for terabytes, kilobytes in the metric or in the computer language. Seconds, liters, meters, grams, any single letter, you'll see that. Otherwise, if we make smaller, we're going to go deci, centi, milli, micro, and nano. Now, in the metric system, it works really, really well because we could be talking about, distances here. And let me go through this quickly here. This is a meter stick because when we get to the end, it goes to 100. And on the back, if this was a yardstick, we'd have to cut it at 36. So this is 1 meter that has 99/100 centimeters. Then one of these centimeters has 10 divisions, and that is a millimeter. So if there is 10 millimeters for 1 centimeter, this whole thing has 1,000 millimeters. Now the slick thing about the metric system is a standard size paper clip is 1 gram. So if you have 1,000 paper clips, you'd have a kilogram. If you have a liter, just like if you lined up 1,000 of these meter sticks, you would have a kilometer. It works no matter what. So let me show you how to get larger and smaller in the metric system. And if you grew up with a metric system, you'd already know some kind of mnemonic, and I did my own, like good man, keys, bought, dark, chocolate, milk, Monday night, something like that. I don't know. You could do that, and then you can go, you can go down 10 to the 9th, and then 10 to the 6th, 10 to the 3rd, 10 to the 0, 10 to the -1, 10 to the -2, 10 to the -3, 10 to the -6, 10 to the -9. I mean, there's some way you can memorize that. Okay, so let me show you how easy it is to get larger and smaller in the metric system. So number one, this is a base unit because there's not another letter with it. It's a single letter. So any single letter is a base unit. So here's a base unit. So we go up here and we want to go kilograms to grams. Kilo is here, 10 to the 3rd. We want to get to our base unit, which is 10 to the 0. So 10 to the 3rd, 10 to the 0. We simply move our decimal point the same direction. To get 3 to 0 on the number line is 3 places to the right. Kilo to get to the base is to the right. Again, 10 to the 3rd, 10 to the 0. We're going to take this decimal point right here and go 3 to the right. And if we go 3 to the right, we're going to get 1,000 grams. And number 2, megameters to meters. Mega is here, 10 to the 6th. We want to get to a base, again, because it's a single letter. So 10 to the 6th to 10 to the 0, we're going to go 6 to the right. If we take this 6 to the right, we're going to get 1 minute. And you'll see that I'll tend to gap every 3. Okay. It's a good idea to put these gaps in just to clarify. In other countries in Europe, this would be 1.000. Okay? So it's a good idea not to put the commas in. All right, kiloliters to milliliters. Kilo, 10 to the 3rd. Milli is over here, 10 to the -3. Just think the absolute value to get there. 3 to get to here and 3 to get to here. So we're going 6 to the right. 10 to the 3rd. 10 to the -3. 6 to the right. If we take this 6 to the right again, we are going to end up with 1 million. Okay, so let's take number 6 here. Nanoseconds to seconds. This is a base. Nano is here. To get to my base now, I'm going to have to go left 9, right? 10 to the -9, 10 to the 0. I need to take this decimal point to the left. 9 to the left. Oops. I should have put a 9 in there, sorry. 9 to the left. So if I take this 9 to the left, my decimal point starts right here. Right there's 1 to the left. So I need 8 more zeros. So for this answer right here, I would get a decimal point. I need 8 more zeros. 1, 2, 3, 4, 5, 6, 7, 8, and a 1, and we should put a 0 ahead of it. So that would be moving this decimal point to the left 9 places. And that would make 8 zeros. Okay, so again, if you make things larger or smaller in the metric system, it is so easy because you would have this memorized and simply move it left or right, the same as what's on the chart. Let's get one like let's see, number 5 here. What do we got? Millimeters to micro. That's going to go to the right. Number 4 here, grams, which is a base, to kilo. Here we're going to have to go 10 to the 0. Go to kilo, I got to go left 3. So if I go left 3, my decimal point's right here, I am going to get 0.001. And then let's put this is kilometers, this is meters, so that's a base unit. Milliliters to kiloliters here. And milliseconds to seconds, so there's a base unit. Meters to megameters, base unit here we start out. Okay, I will let you finish this. Again, this is so easy. If you grew up with a metric system, this would be a piece of cake. To make it larger and smaller. And I should point out that if you do scientific notation back here, so I'm going to check my time quick. If you do scientific notation here, they do not move the decimal point anymore. So I don't want you to get laughed at by a 5th grader, because I've been there, done that. The decimal point does not move. So if I say 2.12 times 10 to the second, you would say that I'm going to multiply this. I'm going to move the decimal point to the right 2 places, because that's the same as 100, and I would get 212. Realize the decimal point doesn't move, the digits move the opposite. So if I lock that decimal in place and move my digits 2 to the left, I get 212. So that's what they're teaching these days. I don't want you to get embarrassed by a 5th grader. The decimal point stays locked in place and the digits move the other way. All right. We'll be back with another recording.